mainly has a core, winding, core, winding. These are the two main parts of core and winding. These are the two main parts of the transformer. Okay, so what is the purpose of core and what is the purpose of winding? The purpose of core is to allow magnetic flux, to allow magnetic flux. Okay, so how comes the flux here? The main purpose of core is that to allow magnetic flux. So the material which you use to prepare the magnetic core, it should have high permeability to allow this magnetic flux. Okay, that is the main purpose, and the secondary purpose is that to provide mechanical strength. See, mechanical strength in the sense, the windings will be there. So to have these windings on the core and to be mechanically fit, you need a magnetic core. Okay. Now, what is the winding? Winding is that the principles, the transformer principles, which I have explained last class. That mainly what you have in the transformer is that you will have at least two windings. That I told you already. At least you have two windings. Why I'm saying at least you have two windings in the sense you may have three windings, you may have four windings, you may have any number of windings. Okay, and all the windings are coupled. Remember, these two vertical lines represents that there is a magnetic coupling between all the four windings. That's the meaning of these two vertical lines. Okay, why I draw three windings towards one side and only one winding on the other side is that you will give supply to one winding. That side you call it as primary. Okay, and whereas the remaining three windings or four windings or five windings or six windings, remaining all windings, you can collect the energy from. So primary side, the energy you will take, and secondary side you will give the energy to the load. Okay, so you may have any number of secondaries, but the primary is only one here. So that's what I said, that at least you have two windings. Out of two windings, one is primary, the other is secondary. This is what I said, but not necessarily only two windings. You may have any number of windings. uh, Among all windings, one winding you call it as primary, remaining all windings you can call it as secondary windings. Now, for the simplification and explanation purpose, we will take only two windings. Winding number one, winding number two. So I will give supply to one winding, and that winding you call it as primary, whereas the winding to which load is connected, load in the sense any electric load which consumes energy. So fan, lamp, or any other electric load. So that you call it as secondary. So this winding you call it as secondary winding. Now between these two windings, okay, how do you join these two windings? Is you will join these two windings with the help of magnetic core. With the help of magnetic core, you will join the two windings. Now the property of the magnetic core should be that it allows magnetic flux through it, but it also acts as insulation to electrically. So magnetic core, it is conductor magnetically. So it is a conductor magnetically. So it's a magnetic conductor. Magnetic conductor in the sense it allows magnetic flux, and it is electrical insulator. It's a magnetic conductor and also electrical insulator. So magnetic conductor and also it is electrical insulator. So between this you have the magnetic core that I didn't draw as of now. Okay. So and I will show you that one by one. And winding, coming to the winding, so what is this winding is that, that's what I said, that mainly the transformer has two parts. One part is core, another part is winding. Core in the sense uh, to which you connect the windings. One example I will tell. I have I have a magnetic core like this. Let me show with some color so that you will understand. Yeah, now you see this blue color picture is the magnetic core. Okay, now the magnetic core in here in this is a rectangular shape. It's in the rectangular shape. Now, what about the windings is that I will draw the windings something like this. This black color. Okay, this is winding number one. This is winding number two. And you may have more number of windings also. So the winding to which side you connect the supply, you call that as primary winding. As supply is here, you call it as primary. For example, if the supply is the right hand side, then the right hand side windings you can call it as primary. So only here only indication is that which side you have primary, that side you call it as which side you have supply, that side you call it as primary. Which side you have load, that side you call it as secondary. That's the meaning of that. Now you see here how the a simple transformer looks like. The simple transformer looks like this. That this blue color picture, that is a rectangular structure, is a magnetic core. So this is a magnetic core. Now, what is the purpose of the magnetic core here is that the purpose of the magnetic core is to allow the magnetic flux. How, why it is allowing magnetic flux in the sense you see primary side you are giving supply. So when you give primary side supply, just like I have explained in the last class that some current will flow in the primary winding, then that primary winding will induce flux. Okay, so that flux will travel through the magnetic core. Then that magnetic core here secondary side, the magnetic core is also linked. So an EMF will be induced. So this principle I will explain later also. Just I'm saying that the main parts of the transformer are only two. One is magnetic core, the other part is winding. So that winding is ఇప్పుడు sign చేయాలా? So so magnetic core is one part, the other part I said winding. In this particular example, there are only two windings. So winding construction is there. So construction of the winding and construction of the magnetic core, that is the main thing. And apart from that, you have some more things also there. Slowly we will know what are those things. Okay. And coming to the construction, now how do we decide the construction? I will tell you some examples of the transformers. You may find out the transformer in your laboratory. Okay, one kind of transformer you will see. You may find out the transformer in our substation, in our college substation. You may find out the transformer, and you may find out the transformer in the electronic circuits or in the CPU or in any electronic systems, electrical systems. Okay, everywhere in most of the applications you will see the transformers. But one important observation you will see is that the transformer, okay, so the transformer which you see in the laboratory is different from the transformer which you see in the substation. Okay, there is a lot of differences are there. So how it difference in the sense physically, if you observe them, you find out lot of differences. It means construction wise there is a difference. So the construction wise there is a difference in the transformers. So why there is a difference in the construction of the transformers is that it depends on application. So your transformer construction, okay, it depends upon the application. So in which application you want the transformer. So based upon that you will have the construction. So based upon that you will have construction. For example, you see in the case of a substation. If in the case of the substation, what is the transformer? What is the transformer? You will find out is that sometimes something will show you here. Uh, one one kind of transformer. Yeah, I will. Now you see this picture. Now this kind of picture you will see in one case, something like this. You see now, okay, this picture. Whereas, okay, so yeah, I will show you anyhow. I will show you here. Okay, will show you here. Yeah, this is one kind of transformer you will see. Where do you see this kind of transformer? You will see this kind of transformer in the substation. In our substation, you will definitely see the transformer. See, is the screen visible?
Yes, sir. Visible, sir.
Okay. So yeah, someone sent in the message that the screen is not visible. You please check. Okay. You can answer me. I can hear you that if the screen is not visible. Okay. Coming to this, this is one kind of transformer. This is one kind of transformer. Okay, where this is one kind of transformer. So mostly you will find out this transformer in substations. You go to any substation, you will find out this transformer. Okay. See, in this transformer, you don't find out any kind of where is the winding in this. What you observe here is that there is a structure. There is a structure. Something is there. Some kind of bars are there. Some kind of cylindrical shape is there here. You see now, some kind of vertical shapes also. Some kind of different shapes you will find out here. Okay, this is one kind of transformer, and mostly you will find out this transformer in a substation. Okay, now I will show you the picture of another kind of transformer. Okay, so yeah, yes, you see now. Yeah, this is another kind of transformer. That now here you see what is there here. The pictures, the structure which is there in the first transformer. In this first transformer, okay. Just give a name here. One. This transformer. So this is transformer number two. You see in the transformer number one, whatever the structure, you don't find out. But this kind of transformer, second transformer, I'm sure that you will find out in our laboratory. In our laboratory, you will find out this transformer. Whereas this transformer, you cannot find out, okay, in the substation. Okay, so we'll see another kind of transformer. Yeah, see this picture. Yeah, this is third kind of transformer. You see there are four transformers here. Only one is, you see here now. These kind of transformers, okay, where do you find out this electronic applications? Very small transformers you will find out. See, in all the three cases, there is a lot of difference in the construction. So, so what does that mean? It means that the construction of the transformer, it depends on application. It is not same in all the application. It depends upon the applications. Now, see this kind of transformers we will use in the laboratory to demonstrate something. Whereas the first kind of transformers you will see in the substations. The third kind of transformers you will see in the electronic circuits. Okay, in the electronic circuits you will find out this kind of transformers. You call these transformers or pulse transformers. Okay, so depends upon where exactly you use. So the construction also varies. That is one point you must consider. One point you must think. Now, but whatever may be the case, the common things in all the three are in any kind of transformer are two things are common. One is core, the other one is winding. Remember, these two are common in any kind of transformer. The purpose of core is that to allow the magnetic flux and also to have the mechanical strength, whereas the purpose of windings is that to allow the electrical current. To allow the, how comes the electrical current here? There is primary winding is there, primary current is there. There is secondary winding is there, secondary current is also there. So to carry that current and also to transfer to transfer energy. So this is also another part. So core and winding, these are the two main parts. And apart from these two parts, remaining all parts, I will tell you, the remaining all things, remaining all the things which you will find out in the entire transformer, their main purpose is that, apart from core unwinding, their main purpose is that to improve efficiency, of this transformation. Yeah, improving efficiency is nothing but reducing losses. Okay, improving efficiency or reducing losses. And protection, there is another word I will use, protection. So protection of the transformer. So these are the two main other things. Remaining all components which you will see here, something there is yellow color is there, you will find out. There is one solid like structure, you will find out. There is one cylinder, you will find out. There are some vertical structures, you will find out. There are some kind of gaps are there, some kind of peculiar, some kind of different structures you will find out. All these things, what they do is that either they contribute to improve the efficiency of the transformation, or they protect the transformer from the uh, accidents. Okay, that's what I'm saying. Apart from core and winding, remaining all the things which you find out in the picture, their main purpose is that either to improve efficiency or to protect. These are the two uh, words you must remember: efficiency and protection. Remaining all the things you will find out only because of this one. Okay. Okay. So, and one more thing I will tell you, that what is the other thing you must know is that there is transformer oil is there. Transformer oil. Okay. What is this transformer oil is that generally you will find out this. See, first kind of transformer, second kind of transformer, third kind of transformers. In second and third kind of transformers, you don't find out any kind of oil. In the first kind of transformer, you find out the oil, transformer oil. Now, here you see now, this structure I have shown you here, this blue color structure is there. So this blue color structure, which I have drawn here, okay, this blue color structure is there. I will bring this here. So this entire structure, you will put inside a tank. Now, something like I will draw with a red color. Okay. So this entire structure, you will find out inside a tank. Okay, this is tank. You call that as transformer tank. Now we'll show you the transformer tank here. You see now, this structure is there, gray color structure is there. So that is a transformer tank. So this entire structure you will find out in the transformer tank. Generally, you will find out the transformer tank only for high power transformers only, not the low power transformers. Why it is so in the high power transformers is that as the power rating of the transformer increases, the losses in the transformer also increases. When the losses are there, as being electrical engineers, everyone know this thing, that the power dissipation in the electrical systems is always in the form of heat. The power dissipation in electrical systems is always in the form of heat. So the more power is dissipated, the more heat will be generated. This is the logic here. You take transformer, you take converter, you take fan, you take motor, you take lamp, any electrical load you take, any electrical application you take, whenever there is a power dissipation in that, definitely that power dissipation, that power loss will be in the form of heat. So more power will be there, more heat will be there. So as the substation transformer, that is the first type of transformer which has this gray color transformer tank and some more structures you will find out here. So this transformer is a high power transformer. Compared with the remaining two cases, the power of the first type is more. So when the power of the first type is more, obviously its loss is also more. When its loss is more, then its power dissipation. So this heat dissipation is also more. So more power in the sense, definitely there is more possibility that the power loss is also more. When the more power loss is there, more heat will be there. So in the first case of transformer, the heat dissipation will be more. So the temperature rise around that will be more. So when more temperature is there, then what is the problem? The problem is that this temperature may melt the transformer, or it may damage the core and winding. There is a possibility that, everyone this thing, that whenever there is temperature is more, then that temperature will melt some of the objects. It will burn some of the objects. So when they burn the core or winding, the transformer will totally get damaged. Then what we have to do? We have to we have to uh, we have to take this heat from the transformer out. Okay, that process you call it as cooling. You call that process as cooling. You have to cool the transformer continuously. Then there are several methods are there for cooling. Okay, several methods are there for cooling. That's what I'm saying. It depends upon the application once again. What are different types of? Mainly, you can categorize the cooling methods as two types. What are the two types? Is that one is natural cooling, natural cooling. Another is forced cooling. Now, what is the purpose of the cooling here? The purpose of the cooling is that to protect the transformer from burning. Okay, why the transformer will get burned or why the transformer winding will get burned? Because there will be lot of heat dissipation will be there. So why heat dissipation? Because every electrical system has some power loss always. Okay, there is no electrical system which has zero power loss. So every system has some power loss. So that power loss is always in the form of heat. So when it is always from the in the form of heat, then something like you are burning the transformer continuously, then obviously the transformer will get damaged. So to protect the transformer from this burning, from this heat, you need to cool that. So then there are two types of cooling: natural cooling and forced cooling. So natural cooling in the sense something like you don't take any kind of cooling arrangement. You don't have any kind of cooling arrangement. Okay, you see the first kind of transformer here. There is a cooling arrangement. There is a transformer tank is there. Inside that tank, you will have some oil is there. Transformer oil is there. What is the purpose of this oil? Is that the purpose of this oil is that it will circulate inside the tank so that it will carry the heat along with that. While it is circulating, it will carry the heat, and that heat will be bring into the atmosphere. Okay, there will be some opening will be there. So to that opening, the heat will be ejected into the atmosphere. So that kind of process you call it as forced cooling, and generally you will use a transformer oil for the purpose of forced cooling. Now, what is the natural cooling? Is that now not necessarily only the transformer oil. Sometimes you can use the forced air also. You can use sometimes forced air also. So forced air is also there. So that you call it as forced that you call air cooling. You can call it as, whereas this is oil cooling. Okay. So whereas you see the second type of transformer, third type of transformer, you are not taking care of the means you are not providing any kind of forced cooling here. So you will just keep that in the atmosphere. So naturally, the heat will go into the atmosphere. You see the second case and third case. So you don't need to take separate arrangement. You don't need to have separate arrangement for this. Okay, dissipation of the heat. Okay, naturally the heat will be dissipated into the atmosphere, so it gets cooled down naturally. So that kind of procedure you call it as natural cooling. Okay. So and this is one thing you must understand, and some more things are there in this transformer apart from this transformer oil. Okay, now I said that for large transformers generally you will go for forced cooling, whereas for small transformers, okay, you go for natural cooling. So that much heat will not be generated so that it gets damaged. Okay, that won't be the case. That won't be the case. Okay. So now one more thing I will tell you. Yeah, once again I will draw the transformer here. Okay. So before I draw the transformer, okay, the core, based upon the core construction, there are two types of transformers. Core type, another one is shell type. Core type transformers. So what is core type transformer? Is that I will show you here. Yeah, the core type transformer something like this. There is a magnetic core will be there. Okay. There is a magnetic core. This is a magnetic core you will find out. Yeah, this red color pic now, this is a magnetic core. Okay. The magnetic core will be like this. Okay. There's a magnetic core. So you have four sides like this. You have four sides like this. So of these four sides, okay, one side, okay, one side you have a primary winding. The other side you have secondary winding. Okay. Now this kind of transformers we call core type transformer. Okay. So on the core you wind the winding like this. Okay, this is called core type transformer. Whereas coming to the shell type transformer, okay. So what is the structure it looks is that, I will show you the structure here. Now you see this black color structure. So now you find out here, what you find out here is that, what do you find out here? Now you see how many sides are there here? 1, 2, 3, 4, 5. So more than 4 sides are there here. You see now. Okay. Now this structure you call it as shell type transformer. So here the winding will be in the central limb. Now I will tell you what is meant by limb here. Okay. I got a word here, limb. What is the limb in the sense? These vertical bars are there, you know, this, and this, this, this. Now, whichever I tick here, the vertical bars, they called as limbs. Generally, why? So on those limbs, you will have the windings. Whereas these horizontal structures are there. This is a horizontal structure. This is a horizontal structure. This is a horizontal line. This is a horizontal line. So these ones, okay, we'll put here. Yeah, this 4 cross. They call it as yoke. Now, what is the purpose of limb and what is the purpose of yoke is that, okay, so the tick mark I put, that is the limb, whereas the cross mark I put there yoke. So the yoke, they provide the closed path for the magnetic flux, okay, and they provide mechanical strength to the transformer. Whereas the limbs, what they provide is that they provide the space for the windings. They provide the space for the windings. You see the core type transformer, that core type transformer, how you see the structure, how you find out the structure. The structure is that it is a rectangular shape like this, okay, and so you have one winding here, the other winding is here. So it shows very clear that there are 2 windings here. So one part of the winding will be on left side, the other part of the winding will be on the right side, okay. Whereas you see on the shell type transformer, where it looks like a window, something like this, there is central limb is there. On the central limb itself, you have both primary winding and also secondary winding. See, blue color, red color, both windings I have drawn here. So it means primary winding is also on the same limb, secondary winding also on the same limb. Okay. So both will find out. Whereas in case of, you see here in core type transformer, some part of the windings will be on the primary on one side, the other part of the winding will be on the other side. Whereas in the shell type, total windings you will find out. Total windings you will find out only on the central limb. This you will find out. This structure you will find out. So this is a shell type transformer, where this is a core type transformer. Okay, this is one of the main differences you will find out. So see here, once again I will repeat that in the core type transformer you have 2 limbs on which windings will be find out, and the structure is like a rectangular structure. Whereas shell type transformer, you find out it just look like a window here, and on the central limb all the windings will be there only on the central winding. Whereas core type, some part of the winding on the left side and some part of the winding on the right side. And one more difference you must understand here is that the windings can be divided as something I will write here: primary winding, secondary winding. What is primary winding? What is secondary winding? The winding on which side the source is connected, that called primary winding. The winding on which side load is connected, that is called secondary winding. Okay. And there is another type of division is there: LV winding, HV winding. What is LV is that low voltage, HV means high voltage. So low voltage winding, high voltage winding. For example, if it is step up transformer, say for example step up transformer. So step up transformer, in the sense, you know very well that secondary winding voltage is more than the primary winding voltage. It is called step up. So among these two, between these 2 windings, whereas coming to the step down transformer, what is step down transformer? Step down transformer, in the sense, the primary voltage will be more than the secondary voltage. So primary winding voltage will be more than the secondary winding voltage. That's called step down transformer. So either in the step up transformer or in the step down transformer, either step up transformer or step down transformer, one winding having low voltage, the other winding having high voltage. So whichever winding has low voltage, that winding you call it as LV winding. Whichever side the voltage is high, that winding you call it as HV winding. So this is another kind of classification of the windings. HV winding, LV winding, primary winding, secondary winding. Okay, so that's another thing. And when you design the transformer, coming to the core type or shell type, what you do is that, see, coming to the core type, left side you have some windings, right side you have some more windings. But don't think that left side you have LV winding and right side you have all HV winding and left side you have all LV winding. No, it is not the case. What do you find out is that left side you have some LV and some HV. Right side also, what do you find out is that some LV, some HV. So it's not like that the entire LV on one side, the entire HV on one side. No, it's not like that. Okay. So to have the uniformity, okay. So we generally, the construction will be like this. Some part of the LV winding and some part of the HV winding on the left side, and some part of the LV winding and some part of the HV windings on the right side, remaining all on the right side. Okay. Now that too, how do you design is that? How do you design is that? See here. Here also same thing. As in case of the shell type, all the windings are here only. So we don't need to think much about this. But coming to this, coming to the case of your core type once again, I will just show you one more thing in the core type. Now you see this is the core type transformer. So I will take two colors here, black and blue I will take. So black color you represent with LV and blue color you represent with HV. So how do you do the construction is that first you put the LV winding here and remaining LV winding here. So it is also LV, it is also LV. Okay. First you put LV winding on the core. Here also remaining LV winding on the core. Then you take HV winding, you put the HV winding on the LV, remaining HV winding on the LV. I hope you understand. First you put the LV winding, then above that you put the HV winding. It's important. Why? Because so that LV winding has less voltage. So when you put directly on the magnetic core, then you don't require much insulation between the LV winding and the magnetic core. Whereas you always put the HV winding above the LV winding. So here also same thing. Put first LV winding, then HV winding. Put HV winding, then LV winding. So this kind of constructions are there. So you have some more things also there. Okay, you have some more things uh, to understand. So apart from this, few more things we will discuss. Okay, another one, what we understood now, there is a core is there is a winding is there is a transformer oil is there. Okay, now there is another word it requires, insulation. What is meant by insulation is that just now I told you that at the end of this class I will show you one video where you can see the real transformer which we have in our laboratory. So insulation in the sense, okay, if you observe the transformers in our laboratory, you will find out that okay, there is a lot of insulation between the winding and the means the windings and the core will have electrical insulation. So sometimes you have different types of insulation paints will be there. Insulation methods are there. So purpose of insulation is that to isolate electrically winding and magnetic core. You have to isolate electrically. The winding should not connect to the core electrically. They should have electrical isolation. To provide the electrical isolation, you generally use any insulation painting, or for example copper wires are there, so that okay, so sleeves will be there on the copper wire, so that sleeves they are used as insulations. Okay, so this insulation is also, so insulation is that the main purpose of the insulation is that to provide isolation electrically. So either sleeves will be there, or you will find out paint will also be there. Okay, so this is another thing. And apart from that, Apart from that, you will find out. Uh, you'll find out. Okay, in the structure, you will find out another kind of ducts. You will find out ducts in the sense some gaps you will find out. Okay, the purpose of these gaps is that to enter the air and so cool down the magnetic core. Okay, okay, and then yeah. Then I'm going to show you a video now. Okay, so the video in the sense that the structure, the transformer structure, which we will find out in the laboratory, in our laboratory. Okay, that I will show you here. Yeah. Yeah, please answer that. A picture is visible to you.
Yes, sir.
Yeah, one. I think you can see this. Okay, is it visible?
Yes, sir.
Yes.
Visible, sir.
Yeah, yeah. Now see here. Now I have drawn a window-like structure in the paint just now. Do you remember?
Yes,
A
sir.
window like, yeah, yeah. I hope you remember that. So once again, I will just show you that window color thing. Okay.
Sir.
So yeah, now you tell me, is the real transformer visible to you?
Yes, sir. Visible, sir.
The real transformer. Now, yeah, is this structure, is the paint structure, is it visible? The shell color, shell type transformer structure.
Visible, sir.
The black color structure, is it visible? Now, please tell, is it visible in the center? Yes?
Visible, sir.
Yes.
Yeah, now I will show you the video. Now, is the video visible now?
Visible, sir.
Visible, sir.
Yeah, now, don't you think that both the structures are same? Not this one. Yes. Yeah, this black color structure, okay, which is in the form of a window. Now same, you will find out the window here. Am I correct? You see now, this is the limb. Okay, this one. Okay, this one is, I told you already that there are three limbs are there. You see the limbs here. uh, this one, this is a horizontal line and you call that as yoke, and this is another horizontal line, you call it as yoke. Whereas this one, this and this, these three are three limbs. So you see, this is the central limb. So in the central limb you will have the windings, this I told you. Okay, of course in this picture, in this particular picture, you don't find out any kind of winding. The winding is there beside that. Okay, that I will show you. Okay, so this is central limb, you will find out. And one more thing I will tell you, so this is the magnetic core. Now you observe the magnetic core carefully. What you find out is that, let me just do this thing. Okay, so now you see the, the third dimension of the magnetic core, how it looks. You just see here. Okay, so this much thickness is there. You see the thickness of this. This is the thickness. Am I correct? This is the thickness. This part is the thickness. Can you understand this thickness here? Can you see the thickness here? Thickness of the part. Okay, or so this is the thickness of yoke. Now let me turn this side. So this is thickness of a limb. Now is it visible that? Please answer that. Is it visible, this thickness, which this is red in color? Yes.
Yes, sir. Visible, sir.
Yeah, yeah. This red color is the insulation. Just now I told you that there is insulation is there. So this red color is the insulation paint. So you will have the paint. And one important thing you will find out here. One important thing you will find out here is that, see, this is not a solid structure. If you see carefully, that it's not a solid structure. You will see some kind of, some kind of plates will be there. Some kind of plates will be there. Okay, so I will just means all the plates. You know, I will show you here. One picture I will show you in the net. Yeah, I will show you now that. Yeah, this is the best picture. You please see this now. You see some kinds of plates are there. They are giant like this. So all the plates are there. One E-shaped plate is there. One bar is there. So this E-shaped plate and bar both will be joined, and all they will be added together here. So this is called lamination. So it means it is not solid one. It's a lamination like this. So these kind of plates you will find out all the plates you join together. When they join together, you will get this shape. Which shape you will get is that, you see now. You see this you see these lines are there. Vertical lines are there. Okay, here also some horizontal lines are there. So what are these? They joined a plate. So this is one individual lamination. This one. So these kind of so many laminations, they just bunched together. They bunched together and they will be bolted. They bunched together. So these are called laminations. What is the purpose of these laminations? Is that to reduce the losses. I will tell you. And these losses, they are called as eddy current losses. Okay, they have a name. Okay, I will write that here also. Okay, when we get more about the losses of the transformer, I will tell you. But remember right now that these are called eddy current losses. I am sure that you might have heard this even in the DC machines also. What are the eddy current losses? So these laminations, the purpose of the laminations here is to reduce the eddy current losses. Okay, now I will show you the video once again now. See the video. Yeah, see the video now. See here now. Now you see. So those laminations which they are shown here, those laminations which they are shown here, they all these laminations are joined, and you see they are bolted. You see what is the purpose of the bolt here? If it is a solid, you don't need to bolt that. It is not a solid one. They are plates. They are E-shaped plates. Okay. So now this you see the E here. This is E. This one is E. This bottom one is the E. Whereas this is a bar, and all they are bolted here. So once they bolt, they become a magnetic core now. So this entire thing is a magnetic core. So the purpose of these laminations are to reduce the eddy current losses. Whereas why do you put the bolts here is that you bunch all the plates. If you don't bolt, then all the plates will be loose and they will go outside. So to make this mechanically strong, you join all the things and you just make as a bolt like this, and so that it will be fit. Okay, mechanically. So this is a magnetic core and this is a shell type. Now, where do you find out the winding then? You generally put the winding here. You generally put the winding here. This side you put the winding. So inside that you put the windings like this. Okay. So that winding part also now I will show you. Now I will show you here now. See this now. Some windings are there here. Okay. Now you see the windings here. Okay. Okay. So now this structure. So here you find out lot of but I will just take this camera here and so is the picture visible? So inside that you will find out lot of wires you will find out here. Okay, so you see there. This winding you will find out here. There is a winding you will find out here. There is a winding you will find out here also. Okay. So you make the winding, and where do you put this side? Where do you put this here is that you put this, you put these windings inside the central limb. Okay. There is central limb is there, and inside that you will put that. So it is just a, you can find out this one in our laboratory also. So there when you go through, you will understand this. Okay. So it's the core, whereas this is the winding. So windings are generally made up of, okay, these windings are generally made up of copper wire. So this copper wire you will wound around this central limb. Okay, this is how it happens. Okay, so